Okay, good morning, everyone. It's just after 10 o'clock, so I think we're just about ready to make a start this morning. You're all very welcome to this Foresight webinar series episode where we'll be discussing today AI for smart energy use. It's my pleasure to welcome you all this morning. My name is Tiernan. I'm the producer here for the Foresight event and also the Foresight webinar series. I'll be leading the discussion today. I'm very happy to do so. In today's episode, as I mentioned, we'll be diving into the AI discussion really this morning, looking at how AI is being used currently to optimize our energy systems, as well as considering some of the potential future use cases for AI as well. And on top of that, we'll kind of be discussing some of the key challenges and barriers to enabling its use in developing smart systems as well. I think energy security, net zero transition, and kind of global energy shocks are forcing us to rethink, how we utilize our energy systems and make these smarter and more resilient as well. And I think the push towards more homegrown clean power indeed demands newer, smarter ways of thinking as well. I think it's safe to say now the question isn't really whether AI can be used to optimize uh, energy and industry, but more how we do this effectively and safely. And in a way that doesn't contribute more risk to energy security as well. And that's exactly what we're going to be discussing today. I think if we get it right, then the possibilities for customers, suppliers, and operators as well could be very tangible indeed. So it's a really lively and timely session this morning. Just a reminder, as always, this episode is sponsored by the Foresight event, our All Energy Clean Tech Show, taking place in less than a month now. Actually, I've been so used to saying next year in these sessions, but we are in the new year now, and it's less than a month until that conference. So we're really looking forward to that and gearing up for a really good conference. It's taking place on the 4th and 5th of February at the Titanic Hotel in Liverpool. It'll be a whole sector discussion involving some of the key sectors contributing to the net zero transition, as well as bringing in things like AI and quantum and how these new technologies could revolutionize the sector as well. So if that's of interest, please do feel free to check that out. But as for the session today, we have two great speakers this morning, Harry Morfakis, who's a partner at Artifact, and Dr. Matthew Selnick, who's digital trust team lead at DNV. So we're going to be tapping into two of the key strands here around the AI for energy discussion around the tech and policy landscape, where AI is being utilized successfully and what needs to happen to integrate it further. And then that really key piece around risk management and trust as well. So that's enough from me. I think we're just about ready to hear from our speakers. So without further ado, I am going to introduce Harry Morfakis, as I said, partner at Artifact. Harry, you're very welcome. I will hand over to you. Please go ahead.
Thanks, Tiernan. So I think to start with, probably let me open with a bit of a number that I think probably will make everyone in this room slightly uncomfortable. So I think if we take a step back, and I think we're all aware that AI is what we need to help us make this energy transition. The challenge is that the technology we need to decarbonize the grid is also one of the fastest growing loads on it, and that kind of brings me to data centers. And like Tiernan, I won't go on too much about them, but I think these are the engines behind AI and all the different AI based technologies we're using day to day in our lives, but also in industry. And now in Ireland, for example, it's already using 21% of national grid capacity. By 2030, it's likely that's going to hit closer to 48, maybe 50%, which is a scary figure that should all worry us. And I think where it gets interesting is that between now and the next 5 years, by 2030, we're going to add renewable capacity equivalent to our entire existing power generation infrastructure. So solar alone is going to double. 90, we hear from all the different energy authorities that 90% of global electricity demands going to be met by renewables. Now, whether that does or doesn't happen is a slightly separate challenge. What we really need to focus on is how can we continuously optimize today, right? So we need to move from this area where AI is kind of a nice to have and a bit of an afterthought, I think it's fair to say, in the energy industry, to it's kind of a non-negotiable. And I'll, anecdotally drop in some of the work we're doing at Artifact with our clients. I've worked in the energy industry for a number of years, particularly on gas, coal, and the phasing out of coal, and then into renewables. So a bit of a history there. But I think what we need to do is focus on where is AI actually contributing today. And I think it's fair to say that if you go to any of the top 100 energy firms globally across UK and Europe, a lot of it is still very experimental. And I think, to cut a very long story short, these are very solved problems. It's not the lack of, or as I say, it's not the maturity of the technology that's the blocker. There's a whole downstream list of other items that prevent us really operationalizing the technology, and those will get solved over time. I think there's an element of industry maturity. We need to get comfortable using it. I'll give you an anecdote. When I first, about 10 years ago, when I went to one of my first clients when I was back in Accenture, we went into an old school coal-fired power station. We were upgrading their networking system. I went in and you had all these labels on everyone's desks. Thank you for being here for 25 years, 35 years, 45 years. And actually just making a small change really worried people. And I think, that's effectively downstream from the energy industry wants to be stable and secure. They don't like change. And AI is going to mandate an awful lot of change over the next 5 to 6 years, basically. And I think that's something that we're going to have to wrestle with and contend with. But to jump into a couple of things. So grid balancing and forecasting. So again, forecasting, a very solved problem. If you take a look at what a good example is Sweden's done, they run a dynamic tariff system that adjusts kind of every 15 minutes based on AI predictions. Now that's really clever, and they did that because they were able to optimize the calculations that were taking 10 to 12 minutes down to about 45 to 60 seconds. So again, the leaps that we've made in machine learning and AI have actually facilitated that. It's enabled that application to now be put into production. But again, it's only happened because one, the industry, the energy firms, and the people have actually been willing to take that on, and it allows the consumer to get a better price. And that's a good example of now that we can do better forecasting, it allows us to do better grid balancing as well. But again, that isn't necessarily the blocker in terms of actually running the calculation. It's a case of how do we begin taking this very, I think, fair to say, old school, often out of date technology, operational technology, and making it a little bit more like the fast moving world of IT. And OT and IT have always been at those kind of crossroads of the digital world is actually very easy to automate and optimize because it's bits, ones and zeros. Physical world, being full of atoms, is significantly harder to do so because you need to have real-time insights. You need to be able to make decisions. You need to be able to trust those decisions. And I think that's really seen in predictive maintenance. So a client of mine that works in bioenergy, they are focused on building effectively a digital twin of their plant. They want to remain a lean organization, automate end to end across their entire 12 or 15 plants in Europe. Now, in order to do that, they need to have absolute confidence in everything from the weight of the material they're bringing in, the type of material, where it's come from. And then if they are able to do that, they can then see it once they put this material into the vat and it produces methane and energy after that. Actually, how can we best optimize our route? What's the best composition of material? It allows all these other dimensions to be factored into how we can better run the plant. Now, again, they're very, I'd say, cutting edge and quite ahead of their thinking and how they want to manage that. But the biggest challenge, being brutally transparent with everyone, hasn't been the algorithmic work. It hasn't been the data or AI work. It's actually been how do we get reliable data from the physical world into the real world using sensors? Because yes, you can stick a sensor on. Is it calibrated? Does it work? Can we trust it? Do the people in some of these remote farms in Italy and Spain who are very, let's say, they're not very good with technology, how can we get them on board? So there's a big, I hate to use the word change management, but it is a very big change management effort that needs to be put in to bring these firms to where they need to be. And I think if I just touch on a couple of other things, so industrial decarbonisation, we work with a lot of heavy industry firms, and it's very easy to talk about. Yes, we should all decarbonise. I think everyone on the call would be familiar with that and agree with it. The challenge is that when you want to start talking about cement, steel, glass, these really heavy industry, very, very energy and more importantly heat intensive applications, you can't just electrify that. So we're beginning to wrestle with this idea of actually, okay, we can't electrify everything. We do still need maybe some legacy fuels in the system to enable that. How can we do it? Actually, we need to optimize. And again, it's coming down to the actual optimization algorithms that you can put in place are absolutely a solved thing. They can actually be done. That's simple. It's can we get into a plant? Can we really change their ways of working? Because it's not as simple as going in, plugging a few sensors and saying, right, we need to run this kiln at 2000 degrees or 1500 degrees or whatever it is. you've actually got to make sure all your supply processes, all your logistical processes around that conform to that. So it's actually a bit of a process reinvention as well, which makes companies very uncomfortable. It's not something they're willing to do. Definitely not energy industries. It's only when they're really, really pushed. And I think what we're hearing, at least from speaking to a number of execs over the last 18 months, has been that they're beginning to feel that squeeze, and that is absolutely coming. So we're going to see that probably manifest itself in the next 2 to 3 years. So I think if we take a bit of a step back and look at, what works today, it's very narrow and applied. So forecasting, asset optimization, process control, they all work, and actually they're used fairly extensively across some of the major firms and some of the more some of the startups firms in energy. I think what's coming next and where we really need to get to see the benefits, and by the way, this extends to pretty much all industries, not just energy, but what's coming next is kind of autonomy. So grids that self-balance, plants that self-tune, systems that basically heal before they fail. Now, there's nothing necessarily preventing us from doing that today. It is these organizational and I think these socio-technical blockers that prevent us doing it. Google actually showed us the template for doing this years ago. Like DeepMind in London, they kind of cut cooling energy in their data centers by 40%. Now, they were able to do that because they basically handed control to their AI optimization system entirely, and now that's delivering kind of ongoing 30% sustained savings, which is unbelievably impressive. But again, that's a company that leans much higher on the risk on spectrum, so to speak. And I know Matt's going to talk about that in a bit, but what we really need to focus on is that the rules don't necessarily get better over time. AI gets better, but it only works if we're willing to accept it and actually implement it and use it. And I'm not saying that we should just hand it over and have humans completely out of the loop, but we need to have a system to manage and regulate that. Otherwise, we aren't going to realize or recognize the benefits that we urgently do need to in the energy transition. So again, the blocker isn't technology; it's the governance and it's the adoption around that. So the firms that are winning, they're not the ones with the smartest algorithm, so to speak. I think they're the ones who've really figured out how to make AI operational, and they've embedded it into their workflows. They've trained up their operators. They've begun to make them, I won't say AI native, but definitely more. They've progressed on that digital technology spectrum. They're comfortable with what technology can do and how to use it. But again, I think what I would say is that companies have to get out there and they really need to start iterating, testing, learning in bites, and then not being afraid and actually beginning to scale that up in secure chunks and really putting the work in to make this a core part of your business and not just an afterthought. No, thank you. Feel free to ask any questions if you wanted.
Harry, thank you very much indeed. I think that was a really good a kind of overview of where we are and sort of what's next and what needs to happen. Really, really interesting. I suppose before we hear from Matthew, just a couple of questions from me on a couple of things you mentioned there. I just want to kind of hone in on that data point that you mentioned. I think that's it seems to be one of the most crucial aspects is kind of the data and data readiness. These AI applications, I think, are only as smart as the data you give it.
100%.
I wonder, I suppose my question is, how mature are, I suppose, UK energy organizations and also, I suppose, maybe, kind of the industrial sector, and sort of how data ready are they, in terms of sharing that data? Do they understand how important that is? And I suppose what do you think needs to happen now in order to kind of facilitate that really seamless data sharing approach, to kind of really optimize this?
Yeah, that's a really, I'd say that's kind of almost the key question, at least that we're facing into in our world on a day-to-day basis. So I think the answer is if we look at it relative, the UK and Europe actually have really quite good data maturity. And what I mean by that is they have the capability to collect that data, and the systems are actually in fairly good working order. Now, the challenge is really you've got these basically these old school systems that you can sensorize, for want of a better word. The challenge is, yes, you can do that. You can pull some telemetry across, but the biggest challenge we have is that let's call it the IT and data engineers, as we call them, they don't always understand what this frequency means or this amount of energy shuttling into the grid. What does that mean? They're focused on the data, they're focused on the tech. They're not actually energy experts. So what we really lack for is people who really deeply understand energy, the generation systems, the power systems, the grid, the different ways we can utilize it, but also people who are good at technology and that can actually use that data. So it's almost like a data translation problem.
Mm.
And I think that's faced globally quite broadly, but I think mostly in UK and Europe, we feel that pain quite heavily. Because even once you've sensorized, you can pull that data in, but then you really need someone to translate it, to model it accordingly. And only once you've correctly modeled it, and you can obviously trust that the data is high quality, frequent, reliable, then you can actually put it to use. So something that we actually do quite frequently is it's very boring, but we do a dashboarding project with our clients. And the reason for that is to actually give people the confidence that the data that we are collecting from these multiple old school operational technology systems is actually correct. And once they have that confidence, then we can start to do the more interesting and actually the higher level activities. I think, sorry, Stuart might have a question on that.
Yeah, no, really interesting. I suppose yeah, let's bring Stuart in there to ask a question. We should just be able to allow your microphone, Stuart. May need to give it a
Hello,
second.
can you hear me?
Hello, Stuart.
Yes.
Please go ahead.
Hi, thanks, Tiernan. Thanks, Harry. It's really interesting stuff. I work for Net Zero Industry Wales. We represent industry across South Wales, industrial decarbonisation solutions, basically. And so obviously what you've been talking about is kind of right up our street. But I was curious as to whether you've seen, you talk about industry, which is obviously kind of a catch-all term,
Yeah.
whether you've seen particular sort of dynamism or from certain sectors of industry? Is it would you be able to say, X sector is really on top of this, whereas Y sector has issues, or is it more of is it more kind of systemic, what you're seeing?
That's a good question. I'd say most of the cutting edge work we're seeing is actually in kind of the biogas domain, to be honest. Less so in wind. I think a lot of the benefits were kind of eked out there a long time ago, simply because they were a slightly more, you know, recent invention onto the stage. They were a little bit more digitized anyway, so easier to use. That's kind of a well-worn, well-trodden path. Sorry. Solar is an interesting one that there is actually a lot of optimization that can happen there in terms of everything from the planning all the way through to the maintenance and optimization of the panels themselves. That's not something we've seen as much of as that we thought of. Now that's probably because we don't have as many in the UK as say lower Central Europe and down into the Mediterranean. But I'd say biogas is probably where we're seeing the most cutting edge thinking, and I think part of that is because this I think it comes down to the supply chains themselves being quite closed loop. You're able to collect, feedstock, food waste, whatever it is, you bring it in, you process it, and you export it to grid. So actually, there's a very closed chain on your inputs through to your outputs. And actually, it's a well understood algorithm around how you begin to optimize that. So I say biogas companies, but to maybe better answer your questions, any energy company, and they tend to be on the smaller side, that's usually private equity owned, is where we're seeing a lot of quite cutting edge thinking because they need to be need to be lean, they need to be very dynamic and agile with how they actually go about this work. So they're doing a lot of the thinking as to, instead of just throwing more manpower at it, how can we actually do this a little bit smarter? Hopefully that addresses your question.
That does. That's great. Thank you.
No problem.
Thank you very much, Stuart. Great question. Brilliant. I suppose it's really interesting what you said there in terms of kind of the energy industry wants stability, not change. I think that's really interesting. Kind of that is always the end goal. But we really are going through such a period of change within the industry now. In terms of not just kind of smart data and AI use, but just even the fundamental change with where we get our energy now as well. And looking at how that changes in the future, it does seem like now is a very good time to kind of fuse the different kind of facets of change together. Whilst we're changing, where we get our energy, it becomes more from homegrown clean power. That seems like a good time to think, well, how do we optimize as well, and kind of, you know, uh, fundamentally change the system, throughout. Do you agree with that, or do you think that it's kind of you know, obviously there are some really important things that we have to consider in terms of, energy security and safety and things like that. But it does seem like now is, people call it kind of the second industrial revolution that we're going through right now. It does seem like now is the time to really kind of capitalize on this change and optimize, efficiently, I suppose.
Yeah, so energy security is a really really important one that I've done a lot of thinking about prior to my life as a consultant. I worked in the military for a number of years, so it was always kind of forefront. And a lot of the research I've done over the years, kind of you look at countries and dare I say civilizations, like they really need to be increasing at the end of the day the amount of energy they use. That's really a driving factor behind well-being, prosperity, etc. I think what we need to do is walk the line between how do we, because we're going to need more energy ultimately. I think everyone's familiar with that. How do we walk the line of we need more energy, but we need to do it in a way that's secure but also sustainable, that is zero carbon. It's a very difficult challenge to walk. So it is a systems level problem because we have incentives, and incentives always drive the outcome. We have different incentives from all parties trying to pull the energy sector in different domains. And I think what we need to do is look at almost like what are the no regrets options, basically. So for me, energy security is kind of paramount. If you don't have that, it's serious risk. The other thing to consider, though, is that there really is no regret from optimizing. And I think what we need to do is focus on where does it make sense to optimize? Where in the value chain, so to speak, does it make sense? Because actually, really targeting these data centers, because they are the fastest growing sector, we really need to optimize them, and we need to optimize them significantly, because if they're going to grow as fast as we expect them to, and I mean, right now, I think what's interesting is if we wind the clock back, as painful as it is for everyone, to COVID times when we all needed these, the blocker was silicon, then it was the GPUs that were being made. Now it's high bandwidth memory, and I guarantee in 6 to 18 months, it's going to be energy is now the final blocker to actually getting these data centers operational. Most of the hyperscalers that we work with, they've got huge amounts of GPUs that are just sat in warehouses doing nothing because they can't, one, build the data centers fast enough, but also we don't have enough energy to service them. This is a global challenge, but also a UK and Europe specific challenge as well. So I think what we really need to do is they're the fastest growing. We need to optimize them the most. And then we need to start working down kind of in the order of operations. Where are the next biggest challenges and how do we go about optimizing them and really focusing very aggressively on that? And yes, machine learning and AI can absolutely do that. What we need to do is always weigh up the kind of cost benefit ratio between it will cost a lot of money to optimize, but what does that mean in terms of a 5, 10, 20 year saving? We need to start thinking slightly longer term on this in the same way we're trying to do for net zero. So I think we need to take a more holistic, a bit of a step back and think what is actually important for us that we absolutely non-negotiable, and then what are the areas that we need to optimize on, because there's going to be changes to the structure of our energy layouts in the UK over the next 10 to 20 years, and I think that's going to be a good thing. But in the meantime, we can't just sit back and do nothing. We do need to optimize, but it does need to be a push from the vast majority of large industries. The startups can do their own thing, but realistically, as exciting and cool as it is, it doesn't move the needle significantly. We need much bigger, more centralized approach, is my personal view. But happy to disagree with anyone on that.
Yeah, no, really good point. Last thing from me before we move to Matthew. And Matthew, if you do have anything you wanted to add to any of these points, please do feel free to come in. But I just wanted to quickly hone down on that point. I think it's a really interesting one around data centers. It's kind of this classic sort of Jevons paradox
Yes.
aspect where AI is sort of touted as this thing that can revolutionize the sector and make it really efficient, work really well. But at the same time, the data center question, crucial for AI, is one of the, one of the sort of greatest, not threats, but considerations for energy security and energy systems as well. It's so interesting that it can both be the solution and the problem. I think that just shows how important it is to get it right. And as we all know, that industries are working really hard to find these solutions, whether it's SMRs or off grid or
Yeah.
kind of technology stacking, whatever it is. But I think that is so important, right? I'm sure you both agree that it's really important to get this right in terms of utilizing and creating this AI, but doing it in a really safe and sustainable way as well. I think that's going to be one of the greatest challenges that we see, as you mentioned, Harry, in the next few years.
Yeah, absolutely. I think there's just to add probably a final point before we hand over to Matthew. I think if we look at where AI is trending, yes, data center. If you look at some of the absolutely colossal data centers that they're building, particularly out in the US, and even some companies that we're partnered with that do some really exciting work where they build data centers in very, very remote locations to access, geothermal energy, basically. That's really exciting because a lot of the, and I think just a distinction for everyone on the call, because maybe everyone isn't AI native, so to speak, the way chips are progressing is you're going to be able to run a lot of what we call inference. So actually asking the AI questions and it responding to you, you're going to be able to run that on your phone and laptop in the next few years and do that as well as you can today on asking ChatGPT or these systems that are run out of these large data centers. So actually that will require energy, but it's not going to require, let's call it data center level energy. Where data center level energy really factors into it is when you focus on these training, so actually training these AI models, that's what consumes all the, let's call it the GPU bandwidth, but also the energy. Now, this is a fairly low latency activity. It doesn't need to be real time. So to your point around going off grid, that's very, very likely a serious solution for a lot of what we're doing, because actually you don't need millisecond latency to actually communicate with the data center of the model. You hand it over, it trains for many, many weeks and months, and then it kind of comes back. And I'm being very painting with a very broad brush and not doing it justice, but you can actually offshore that, so to speak. So I think we should evaluate what are our energy demands and what is the type of application we need, and therefore where should that go? And we need to start thinking more realistically about that. And there are some really great companies out there already doing that thinking around data and AI training. Where's the best location physically to do that? And then inference, maybe doing it on your phone or your laptop. Maybe that starts to decentralize things a little bit. Now that's a bit of a theory in terms of, let's see if that plays out over the next 2 years, but that could also alleviate a lot of the stress on the grid, so to speak.
Harry, thank you very much indeed. That was really, really interesting. Before we move on to Matthew, just a reminder, everyone, I've been very selfish in using my chair's prerogative to ask loads of questions there. Please do feel free to pop your own questions into the Q&A tab that you see at the top of the screen. Once Matthew's spoken, we're going to move on to a wider Q&A session there, bringing in some of the wider points. So do get your questions in, and I'll make sure they're asked to our speakers. But in the meantime, Matthew, you're very welcome. I will hand over to you now to deliver some opening remarks.
Thank you, Tiernan. I've got a few wee slides. I'll just try and share these. Hopefully that'll work. If you give me a thumbs up if they
just give it a second. They're just loading in. Perfect. All right, go ahead.
Awesome. All right, I'll try to rattle through this because I think the Q&A is really valuable. So, yeah, I kind of agree with a lot of the discussion so far. I'm an engineer, so I'm going to come at this from an engineering perspective. I've worked in the energy sector for my whole career. And I want to talk about risk a little bit. I'll talk about D&V a bit in case people don't know who we are. But why are we talking about risk with AI? And it's really we're talking about safety critical systems here and critical national infrastructure. When we talk about the energy system, the lights have to stay on. And engineers tend to be somewhat risk averse because of the potential consequences. This doesn't mean risk avoidance, but it does mean risk management, and which is fundamental to engineering, really. No system is risk-free, but if we manage risk, we can unlock that technological progress. Now, the energy sector, as we've been discussing, is undergoing this major transition. The energy transition moving from large-scale dispatchable power into renewables. And that plus this digitalization is increasing complexity in the system and therefore introducing uncertainty. Now, AI as a toolkit offers a way of managing that uncertainty in energy system while also introducing its own challenges. But very quickly, just to give our credentials, if you don't know DNV, we are a global independent assurance risk management firm. We're one of the largest companies in the energy sector you've not heard of. We cover many aspects of the energy sector, plus shipping and maritime, and software and cybersecurity and so on. So we're the people who do the independent verification of physical and digital systems and provide certification thereof. So we operate globally. We're doing this for 160 years, though I will emphasize that I personally have not been doing this for 160 years. So we've really focused on practical risk management in high risk sectors. So we do know what we're talking about. Personally, my own career's followed the energy transition trajectory as well. I started with a PhD in numerical modeling. We didn't call anything AI back then, or even machine learning. I've then worked in the power sector looking at CCS. Then I've done risk management for offshore oil and gas. And now more recently, moving into digital and working more in the renewable space as well. So we are seeing, these are two historic transitions. In terms of human history, these are two historic transitions, right? The energy system or the power grid is the biggest machine humanity has built. And we are now having to rebuild that machine at rapid speed. And in the process, we're introducing all this uncertainty and complexity. Now, AI enables us to manage that uncertainty and complexity, and in a way that humans no longer can. We're no longer operating a power grid like a central dispatch office. We've got much more distributed system. We've got changes to the demand side in terms of even just domestic use. And we're seeing the supply side changing as well, because we're now relying on weather, solar, wind, etc., which are much less predictable than, say, a supply of coal or oil and gas. So we're seeing demand changes and supply changes. And balancing this out, as Harry was saying, is a job. Really, it's a job for a digital system like an AI. So we can use AI. Really, it's to support the operators, help them with autonomous dispatch, and so on. So fire on through. So we're going to move from, say, manual operation control, which the system was designed to do back in the 1960s, and now we're moving to a more autonomous regime potentially. And we're already seeing aspects of this in operation in various places. So we're already seeing autonomous control of valves and other things in, say, the gas sector. This move, again, because it's so complex, we need to be able to manage the risks of that complexity. And AI itself, while a solution to that complexity in energy, introduces a whole bunch of new complexities that we maybe don't see to start with. We're operating the system in a different way, and we're operating it with the models that they're effectively black boxes. We don't know how they're coming up with their decisions. So how do we manage this risk? Well, we apply the same techniques that we've always done to the system. So AI risks are real and need to be managed. I'm going to pull an example here from the automotive sector. Fortunately, we don't have any great examples of of AI failure in the energy sector at the moment, but that's probably due to the fact it has a low penetration into the system so far. But what we see is these autonomous systems, where they are in use, introduce both systemic risks, so failures from interaction between the components, not just the components themselves, but also these new emergent risks where we're getting unexpected behavior because the system is more complex. This is areas of active research, especially in the UK. University of York, for example, have a Centre for Assuring Autonomy, which is looking specifically into these aspects in safety critical systems. The challenge is that these risks can be then magnified by market pressure, by governance failure, and say a regulatory framework which maybe isn't geared to this new reality. So just on one specific example, in 2018, I think, this was the first known fatality involving an autonomous vehicle. And it's an interesting case study for sure. But what it illustrated, rather than just apportioning blame to certain individuals, is it showed, just like most critical failures, it's a systemic series of failures, not just one part that caused this accident and an unfortunate fatality. All the way through from a lack of expertise at the regulator, this rapid pace of technology, the lack of controls, control systems or backup systems, and also operator failure. So this emergent behavior is already causing challenges in other sectors. And as we see this coming into the energy sector, we're going to see similar faults eventually. And I suppose the important thing is that we can learn the lessons of history. We have built up our health and safety legislation over decades, learning from accidents across multiple sectors. We're at this point now with AI where we haven't quite introduced it enough, but we're seeing these problems. So we've got this opportunity now to really ensure it's trustworthy from the start. How do we do that? Well, Harry's touched on a few of these things already, actually. The data quality, absolutely essential. You know, we can apply assurance processes that we've been applying for decades. As I say, we've got a 160-year history of doing this. And we can bring that experience into the digital realm. And we already cover most of these topics. But as Harry says, data quality, absolutely essential. That underpins all of the modeling. Data sharing is super important as well. Sensor data, super important. We're now seeing these systems being censored up. But because we're talking about power grids and remote sites, these sensors are also in remote sites, so they themselves fail, or their connectivity fails. So we have to be able to ensure we're getting quality data from the sites. And of course, the algorithms and the models all have to be verified and make sure that they're doing what they say they do. And if we can capture all of these elements, we will be able to assure these AI-enabled systems. Now, so it's just my final slide. I can say that this isn't theoretical stuff. We've published, DNV's published a suite of recommended practices around assuring digital systems. This is about 6 years ago we published these, and we're not the only organization to do so. There are ISO standards available as well. So we already have the toolkit. We can make AI in energy safe and trustworthy. We just need to apply it. And I will stop there to allow for Q&A.
Matthew, thank you very much indeed. I think I'm just looking at the chat there. I think there's a few issues for some people with those slides, having a look at them. So if I maybe put my email into the chat, if anyone wants a copy of them, If you wouldn't mind potentially sharing them, that'd be great. If anyone does want a copy of those slides, please feel free to give me an email and we can get them to you if that's all right with you, Matthew. But very interesting regardless, and interesting to see or hear sort of the synergy there around, kind of data sharing, data use, and how important that is. Again, just a very quick one from me, while we wait for some questions to filter through into the Q&A there. In terms of this risk approach, I'm interested to hear, do you yourself and DNV, do you have any thoughts on where the line is drawn between kind of AI that can safely automate decisions, and AI that kind of must remain advisory? Do you have any thoughts on that? What are some of those things that sort of can't be autonomized, so to speak? Is there anything, and kind of what determines that boundary? Any thoughts on that?
For sure. Before I answer that, I can tell people I was just showing some photographs in the slides, so you're not missing anything critical. So apologies for the tech issues and the irony of being on a chat about AI and having technology problems. In terms of your question, we're well used to managing risk with technologies where there's a lot of uncertainty. Our frameworks already account for the fact that there's a criticality curve of AI. So as you move from systems that are purely advisory through to the human AI interface, through to fully autonomous systems that are making decisions in real time, you see the criticality increase. And we'll apply the same techniques that we do in safety critical sectors, where you say the same problem. As the risk increases, you apply further controls. You make sure that there are guardrails and boundaries around the systems. Right now, the ultimate backstop is the human operator. But as we move into this new autonomous realm, the human operator is more there as a facilitator, or almost the orchestra conductor of the AI. It's not going to be, they're not going to be making direct inputs. They're just sort of the broad strokes pushing the AI to do certain things. So we're aware of the solutions. We don't necessarily say there's a hard place where no, you can't do this. There will be a case-by-case basis, and it won't be a yes or no. That's really the job for the regulator to say that. Our job is to say, what is the risk? How have you managed the risk, and can you reduce it to a level that's reasonably practicable?
That's interesting. I suppose just a follow-up then. What do you think? Do you have any thoughts on what sort of the biggest misconceptions organizations have around AI risk in energy right now? Do you think is it sort of technical, organizational, or regulatory? Any thoughts on that and how we can kind of address them as well?
In terms of the misconceptions, I guess the biggest challenges we have really are around understanding what is AI and what is it capable of doing. Most of us are interacting with co-pilots, so generative models generating text, maybe videos or images. But what we're talking about here are not necessarily those models. We're talking about models that are working on data. They're pulling information from other models or simulations or real-time data feeds, and they're making decisions, control decisions for complex engineering systems. They're not generating text. So it's understanding that there's actually a fundamental subset of models that probably most of the population don't see. The biggest challenge there is really I say two big challenges. There's an immense skills gap, of course. We need to upskill everyone. to understand this new paradigm, these new emergent risks, and so on. And it's not just about understanding the models, it's about the data. I think Harry touched on this from one angle. I've touched on it from another angle, is that the people generating the data need to understand the value it has.
Mm.
And we've, for example, asset inspections, which are done manually a lot of the time, but could be AI, generate a lot of data and reporting, which is all text-based because people are just writing down notes. But if we can write that in a way that's computer readable, we could then use AI to help us understand trends and patterns and maybe, optimize our maintenance and management of systems. So it's understanding that everyone has a role to play in that system. But the other main concern or challenge we have really is just the regulatory environment, that from our perspective, regulation and good governance are enablers of adoption. And this is because we're talking about high risk, safety critical systems. Engineers are not going to implement a system that is unsafe or they don't understand the risk. And regulation and governance enables us to define that so that we can start to use these systems. And we're just, the regulators I don't want to bash the regulators because certainly in the UK, Ofgem is doing a great job at putting out guidance around AI, data best practice, and so on. So they are catching up. But there's this, if there's a skills gap in industry widely, there's also a skills gap in regulator and government bodies that are managing and regulating this as well.
Yeah, such an important issue, is it? And you mentioned, Harry, that it's not just sort of a skills gap in your data people. It's a skills gap in your data people who also need to be sort of experts in the energy sector as well. It's kind of there's quite a few skills that are needed there for one person. I'm sure that brings its own challenges as well. And where do we even begin in terms of addressing that? Is it kind of completely restructuring the courses that we give people, or the on-site training, or whatever? I think that's a really interesting one. A couple of things have come through in the chat then, and I can see one hand up as well. So Karina, we're going to bring you in just a second, but I think there's an interesting comment here from Claire Rasdale that I'd like to bring in as well. Claire says the cost-benefit ratio. The cost-benefit ratio is very important. She says if you visualize a Venn diagram with the data you have on one side and then what AI can do on the other, in the center, you need to decide what is commercially viable for you and AI to do with that data. Both domain expertise from the data source and AI expertise to realize that are needed. I suppose, do any of you have any thoughts on that, about kind of how important it is to kind of really think quite strategically about this, about, I suppose not just doing AI for AI's sake, right? And understanding exactly what applications work for you and which work best is kind of how I'm interpreting that. Is that right? Any thoughts on that from either of you?
Yeah, I would agree with that. It just comes down to what's the job to be done. Like, what are we focused on doing? And I think that kind of probably leads into maybe Paul's comment on the next section, which is, AI's been around. There's lots of different tools. Which one is most appropriate? Sometimes people do stuff for the sake of doing it, and there's nothing wrong with experimenting. By the way, we actively encourage that. But I think both Paul and Claire are spot on in the sense of you need to understand what is the art of the possible, what can actually be done, what is achievable, and then what should be done by you and your organization to move things forward. And then there'll be an optimal way of doing that. And sometimes it's LLMs and Gen AI, and often in energy it's not. That's good on maybe more of the back office side. But yeah, to Paul's point, there's a whole host of techniques. Matthew, you mentioned obviously doing numerical modeling, right? As they used to call it, it's very much the same thing, right? In that, basically using maths and statistics to try and get to the right answer. But we need to decide where we want to go first. And I think it's that maybe a lack of understanding, and it's something we see not even just in the energy industry. It's this lack of, I think, I call it like digital product leadership, really lack of understanding around what can we do and how do we go about it. People don't really know where to start, which is often a big challenge.
Yes, I would say we've gone through this period of AI explosion for 3 years since GPT-3, that I've heard board directors tell me that their board have said we must do AI, and they're pulling their hair out because they don't know what does that mean.
Yeah.
So the point there is spot on from Claire that you can't just do AI. You have to be really clear why you're doing it. You start with the problem to be solved and then choose a solution for that problem, which AI may be one of the tools. On Paul's point, I would like to reframe his question a little bit because when we're talking about machine learning and traditional models, we can audit and explain what they're doing. We know there are standard techniques for providing metrics on machine learning models, etc. For AI, yes, okay, OpenAI and co will put out metrics on bias and drift and things like this. But from an engineering perspective, those aren't that particularly helpful. And maybe we need to reframe it. If as we move into the AI agent era, we're no longer looking at how can we absolutely confirm the model is giving me the right answer, but what we're doing is testing the reasoning capability of those models. Is the model as good at making a decision as a human operator, or at least up to a level that is sufficient for our purposes? Because we know humans also make mistakes, but we account for that in the system and the controls we put in place. And I think in this era of statistical non-deterministic models, we need to account for the fact that those will also make mistakes, and that we can't necessarily say that means we can't use them. What we say is we need to be able to control and manage that.
Yeah,
and of course that will take time, right? Because we have the benefit of many years of experience in kind of accounting for human error and making sure that is well accounted for. I suppose it will be the same process for AI as well, and I think that's important, as you said, Harry, that it is important there to sort of experiment safely with these things and figure out exactly how they work and how you can sort of do it safely and make sure that they're implemented safely as well.
Yeah,
I suppose
there's
that's
definitely just to add, I think there's scaffolding that you can put around that to rules to prevent serious like catastrophic errors. But I think just anecdotally, I think the industry we're seeing make the most leaps forward with the LLM and the non-deterministic technology, right? It's really around insurance, and I think the reason for that is insurance people are very, very good at understanding risk. They understand that it's going to be wrong 2 times out of 10, but we're going to get huge upside from the other 98 times it is correct. And obviously in the energy industry, we don't always have that luxury because we have to have much higher, 4, 5 nines of reliability, right? So we don't always have that luxury, which is why the adoption will be slower, and that's the nature of it. But to Matthew's point, which I think is absolutely spot on, it's about how do we put the safeguards and the rails in place so that we can get the benefits, but in a controlled way.
Yeah, really interesting point. Karina, you've been very patient with your hand up there. I'm going to allow your mic now. Please feel free to come in and ask your question. If you wouldn't mind just stating where you're from, what organization you're from, just for the transcript, that'd be great. But go ahead, Karina.
Hello, thank you. Thank you for turning me on. And thank you both speakers for interesting presentations. I have quite a big background in industrial gases, and now I'm acting as an independent consultant. And my question is mostly about hydrogen. So hydrogen is a part of energy transition, we all know, and this is to use in grid balancing to help to decarbonize hard to abate industries. It's a part of transport, heating, etc. Lots of applications. And I'm mostly wondering, and this is for both speakers, do you see in your real life practice any commercial projects where AI is involved into hydrogen related projects, applications in the hydrogen economy, or this is just on the pilot level? So this is it.
Thanks, Karina. Interesting question there around specifically hydrogen. Does anyone want to come in on that?
I have an anecdote, but it's more from my previous career where we worked with very closely with BMW, and we were using a lot of kind of machine learning to identify the best refueling stations for that kind of, because they had a big push on hydrogen. And that's the only one that comes to mind. I think yeah, it's a tricky one because hydrogen shares many qualities with other fuels in the way obviously you transport them. There's obviously some key critical, very important differences there. But actually, if you look across the value chain, Karina, I think there's a lot of existing in the way obviously you optimize your supply chain. You manage your storage, which is obviously critical with hydrogen, that you will be able to use machine learning. I can't say myself I've done more than just that initial use case, but there's definitely room for kind of using AI across that. Matthew, I'm not sure if you have any thoughts.
I struggle off the top of my head to think of a crossover hydrogen to AI. I think the hydrogen sector has plenty of challenges to scale, and AI is maybe not the most pressing one. But
it is interesting.
Sadly,
it is interesting though, isn't it? Because the future pathway for energy, it isn't going to just be renewables. I think even if you look at NESO's sort of balanced pathway for a decarbonized grid, you need that dispatchable sort of
energy dense
low
fuel,
carbon, exactly, power just to kind of supplement those renewables, especially as we wait for kind of movement on storage and things like that. So when you're looking at future energy systems, it is very important as well to keep in mind. And I know you mentioned, Harry, that kind of biogas is one area where we're seeing a lot of movement there. But the hydrogen sector is a big one as well. And I think there's a lot of sort of hope and expectation put in that sector too. So it will be interesting to see as that sector matures, what happens there. I suppose really quickly, Matthew, you mentioned that you worked in CCS as well, and that's another area where we could see real movement in terms of low carbon generation. Can you see any sort of use cases for AI within that sector as well?
Yes, I suppose also where hydrogen comes in more broadly is that you're making a good point that the energy system is a system. It's not an electricity grid. We're going to need transportable fuels for decades, and the energy transition is a transition. There will be oil and gas production for 20 or 30 years into the future, right? And hydrogen will come up to capture some of that market, and CCS will be needed. There's a huge balancing problem as you electrify huge parts of the system, because you're becoming interdependent. How do you produce hydrogen? Electrolysis. What does electrolysis need? Electricity. So you're using hydrogen both as a consumer of electricity and potentially a producer. So that supply demand balancing is a very complex problem, especially because you'll have small concentrated hydrogen production facilities, for example. So, and then in CCS, there's a similar problem. You'll have to, if you're going to use your gas for power generation and it's going to be abated, it's maybe not going to be on 100% because it's dispatchable. So your CO2 flows are going to be variable as well. So it's just part of that huge complexity problem that is being introduced.
Yeah, that's really interesting. Karina, thank you very much for the question.
Thank you very much for answers.
Perfect. Was there any sort of follow-up, Karina, or did that effectively answer your question?
No, I think it's enough. It was just mostly my my own check, because I kind of also don't see lots of big projects which is happening. Mostly, lots of expectations, and I hope it will go somewhere, as Matthew said, that energy system is a system. Yeah, it's completely right. So thank you. for discussion.
Yeah.
Thank you very much, Karina. All right, we're almost at time. I wonder if we can just finish on one more, a very quick line from you both. It's kind of a broader question just to finish. I suppose I'd ask, if you both had to prioritize sort of one AI use case that would most improve the UK energy system by performance by 2030. I mean, we've got this Clean Power 2030 action plan. It's we're fast approaching that time. What would that use case be, and why? I suppose. What do you think we should really be focusing on now as a sort of quick win within the next few years in terms of AI adoption within the energy system? Any thoughts?
Question.
Don't make us pick one.
Yeah, no pressure.
Demand forecasting, and supply balancing, I think.
Yeah, balance. Yeah, I'd probably lean towards the supply balancing, like the optimization basically is going to be everything.
So that's where you both think we could see, those quite significant gains.
I think it's where there's, dare I say, quick wins. I think it's something that can be optimized to realize those benefits, and in doing so, will actually help people realize the value that machine learning and AI can actually unlock more broadly across the industry. So I think it will serve the benefits of obviously helping balance the grid, which is an urgent issue, but also paving the way to hopefully more transformational change.
Yeah. I suppose we need to see it, just like any of these things, seeing it work and seeing it work in action is the best way to see see more change and more adoption. It's seeing it work, I think, is the message there. That's an interesting point.
Yeah.
Perfect. Well, I think that's a good place to end. Thank you very much indeed, Matthew and Harry, for your thoughts. That was a really, really interesting discussion, and thank you so much for your thoughts, comments, and questions from the floor as well. It covered a lot of ground there, I think, in terms of sort of some of those key points that were raised. We are, as we mentioned, in that stage now where it's kind of not a, as you mentioned, Harry, not a nice to have. It's how do we do this effectively, safely, and sort of quite promptly as well, in the best way possible. And as you mentioned, there's quite a few wins to be had there if we do this effectively and smartly, and in terms of this technology adoption. And that's before we've even mentioned other things like sort of digital twinning and even quantum, where movement's happening. That's probably a bit further down the line, but combining both of these areas together, for a smart energy system, we could see some real benefit there, especially for consumers, I think, which is most important as well, feeling that the benefit in bills as well, both domestically and for industry as well, keeping them here through cheaper energy, I think is the end goal. So lots to do, but also lots of wins there as well. So really, really interesting conversation. Thank you very much to both of you, and thanks for joining us from the floor. I think we'll leave it there. As I mentioned, we have our Foresight event coming up in February. I've just popped a link in the chat to that now if you want to take a look at the sessions that we've got going on in that. It would be great to see you there on the 4th and 5th if you can make it. But for now, we'll say thank you very much once again, and enjoy the rest of your week and weekend when it comes. And we do hope to see you again in the future. Thank you very much, everyone. Take care.
Thank you, everyone.
Thanks.